This video is over section 2.3, Basic Limit Laws. And if you've read through this section already, you probably have thought that it's really self-explanatory. Basically, you can do whatever you want with limits. You can add them, you can subtract them, multiply them, whatever your heart desires. You could say there's no limit to what you could do with them. Okay, well, if you're still watching after that bad pun, let's go through number 13 in your textbook as an example and solve it using our basic limit laws. Okay, so number 13 is asking us for the limit as t approaches 4 of this function here. All right, the way we're going to approach this problem is we're going to separate out this big function into a bunch of little tiny functions and solve the limit that way. So first, we're going to start with the first big part that we see. Looking at this function, the biggest part that I see is this thing divided by this thing. So I'm going to use my quotient rule and separate out the numerator from the denominator. So on the top, I'm left with limit as t approaches 4 of the entire numerator, and I'm dividing that by the limit as t approaches 4 of the entire denominator. Okay, yeah, but now looking at this part, I can separate out both the numerator and the denominator one step further. So bringing it down here, I can use my addition law and separate out the 3t and the 14. So on the numerator, I have the limit as t approaches 4 of, I'm going to skip a step here. I could write a 3t here, but I'm going to go ahead, move the constant out to the front, and just write the limit as t approaches 4 of t. Okay. Then I have minus the limit as t approaches 4 of 14. And now on the bottom, I do the same thing. I separate out the t and the plus 1, divided by the limit as t approaches 4 of t. What color have I not used? This one. Plus the limit as t approaches 4 of 1. Okay. Looking at this function that I have now, I have a bunch of tinier functions, and there's not really anything else I can separate out. So I'm going to go ahead and solve my limit this way, see what I get. All right, looking at this first part here, limit as t approaches 4 of t. Whenever I just have a variable here like this, I can plug in my value of interest into t, and that's what I get. So when I plug in 4 for t, I get 4. But remember, there's a 3 out here. So I have 3 times 4. Now I have minus limit as t approaches 4 of 14. Remember, whenever you have a constant here, no matter what number this variable is approaching, the limit of this constant is always going to be just that constant. So I have minus 14. Down here, I have just a variable again. So as t approaches 4 of t, that'll just be 4. And then plus, again, I have a constant. So whatever this value is approaching, the limit of a constant is always just that constant. Okay, now I'm going to go ahead, simplify this, and get my answer. 3 times 4 gives me 12 minus 14. I have negative 2 over 4 plus 1 is 5. I can't simplify this fraction any further, so that's just my answer. The limit as t approaches 4 of f of t is equal to negative 2 over 5. And that's it.